So, Lance, thank you so much for that warm welcome, and thank you for the gift that's in the post for my 10th anniversary at Neo4j, meaning it's only running about 18 months late. I'm going to have to run a path algorithm on that to figure out just where that gift has got to. So look, hello everybody. My name is Jim Webber, and I am Neo4j's chief scientist. And over the next kind of 10 or 15 minutes, I want to have a little tete-a-tete about the social economic impact of cybersecurity, and indeed how we at a technical level and at a business level can start to deal with some of the increase we're seeing in cyber criminality, and how I think that graphs can be a really useful tool in our toolbox for solving or defending against and understanding and reasoning about some of the cybersecurity challenges that we're seeing in the modern enterprise. Of course, the world runs on software, it runs on computer systems. These systems transact huge value, and so they are a honeypot for the ne'er-do-wells that would like to exploit that value. And it's down to us to figure out how we can harden our systems, how we can minimize the blast radius from any impacts that we have from cyber criminality. And really what we're trying to do is maximize the effort that an attacker has to make while we minimize our own effort through automation and tooling. And we don't need to be 100%. I think we just need to be a bit harder than another juicy target, and then we're relatively safe in comparison to where those efforts on behalf of the criminals will be applied. So here we are then, in unprecedented in our lifetime pandemic, and our lives just moved online almost overnight. In fact, I remember sitting with my management team colleagues here at Neo4j, and we were watching this kind of pandemic unfold. And I kind of tentatively said, maybe we're going to have to shut down the offices here. It's coming to that level. And people were like, yeah, maybe. And then suddenly, like a week later, all of our offices are shut, and our entire business, like many of yours, I imagine, are online. So, of course, this last year has been record-breaking and unprecedented and awful and tragic in so many ways. But it also led to an unprecedented increase because of our increased use of IT. It led to an unprecedented increase in cyber criminality. So we have seen, according to Sonotype, a fourfold rise, a 420% rise in supply chain attacks over the last 12 months. We've seen a 238% rise in cyber attacks targeted at banks or healthcare organizations. In fact, just this morning, I was speaking to some friends at the school gate, in the socially distanced school gate as it happens, and they were saying how they're now getting repeated robocalls, convincing robocalls from what seem to be from banks or from the Inland Revenue Service here in the UK, either promising money or threatening legal action. We've seen, I think completely understandably, a 630% rise in cloud-based cyber attacks between January and April 2020 as we moved online and all of our systems moved online and we started to default to cloud first. And in fact, an overall 300% increase in cybercrime as reported by the FBI in the US since the pandemic began. So it seems that as we've moved our lives into the virtual domain, the criminals have upped their game into the virtual domain as well. And as it turns out, this kind of battle of wits between us and the criminals is not going brilliantly for us. So according to Cybint, we have 95% of cybersecurity breaches caused by human error. And that seems terrible, and it kind of seems very blamey. But humans are fallible, and I think without the support of good tooling, that kind of human fallibility is always going to be the weakest link in our chain. To be fair, I hadn't realised just quite what an impact we people have in cybersecurity, and indeed the giving options for those other humans to exploit us. I mean, you know this, right? You know that humans are fallible. If you're the computer person for your family, you know it only too well that your dear old uncle is running on a Windows installation that's multiple years out of date with a browser that's historic and so on. It's a dismal situation, and that kind of kind of poor situation, it turns out has carried over even into our professional lives. For what it's worth, a bit of advice cybersecurity wise, my wife has been using 1Password for a whole year. It's changed her life. She said, oh, this is very convenient. And it's changed mine too. I no longer worry about her passwords being compromised. Of course, in the bigger element of IT systems, we can't just do that. We need more advanced tooling in our pocket. For example, we know that according to Proofpoint, there's been an 88% of orgs worldwide have experienced spear phishing attempts. In fact, we at Neo4j have experienced them too, and some of them are remarkably clever. Some of them I have to look twice. Actually, I got one that just so convincingly, almost convincingly, appeared to come from my boss, Emil Efrem, the CEO of Neo4j. And the only reason that I kind of twigged that it wasn't him is that he demanded a phone call. And I said, I can't phone you. I'm playing outside with Jack and Lucy. Jack and Lucy, I have no idea who they are. They're certainly not my kids. But when it came back with no, please, let's do it this way. Jack and Lucy will be fine. I knew it wasn't them. But not all folks have the wherewithal to kind of process that in real time when business decisions are pressing. A huge majority of leaders feel their cybersecurity risks are increasing. I think that's valid. That's the one good point, I think, in this set of surveys, that at least our leadership are aware and nervous, usefully nervous about the task ahead. And almost all breaches were financially motivated, so 86% of them, and then 10% motivated by kind of James Bond style espionage, according to Verizon. So this is a really kind of interesting high-level survey across what's been going on in cybersec over the last year. The money involved is simply staggering. These are numbers that I normally think that I will see on the news talking about debt and all this kind of stuff. But here we're seeing that by 2025, cybercrime will cost the world $10.5 trillion US. That's a staggering amount of money. Even if we can shave small percentages off that, then we're pocketing a serious chunk of cash there. The security market, the counter to that, Gartner predicts is going to reach $170 billion by 2022. So we're spending big to try to prevent some of this cyber criminality from happening, to defend ourselves from it. IBM tell us that an average breach might cost nearly $4 million. And of course, there are breaches that we know of that have cost far more than that in the exceptional cases. And if you're in the cybersecurity market, this criminality is a boon to you, I guess, because your products that defend against criminality are going to be worth about $500 billion, or $0.4 trillion by 2027. This is an incredible thing, right? Over a 5-year period, the cybersec market is going to increase by somewhere in the region of 12.5% compound annual growth. So this is an important thing that's happening. People are taking it seriously. So let me give you some more terrifying, frankly, statistics. It takes 207 days, like a whole working year, if you like, to identify a breach in 2020, according to IBM. That is shocking. 58% of breaches involve personal data. I live near the EU, no longer in the EU, but near the EU. We have incredibly strict regulation about personal data. These kind of things are legally problematic should you leak them. 64% of folks over the pond in the US have never even checked if they're affected by a data breach, right? So this is interesting that, a minority of folks are aware of this threat, but overwhelmingly, it's down to us to protect our customers and our users from this stuff, because 2/3 of them simply aren't aware of the kind of problems that are happening out there. And about half of US nationals wouldn't know what to take in the event of a data breach either. To be honest, as a computing professional, as someone with an actual PhD in computing, I'm not even sure what I would do. So I think, again, this shows the kind of duty of care that we have to our users. Now, in terms of threats and trends, it's crucial to have a grasp of the general landscape of the metrics surrounding cybersecurity issues, including the kind of attacks that are happening, where they're coming from, and so on. There are new malware, viruses discovered every day. For example, there was a research study conducted by Deep Instinct, And that reports on the hundreds of millions of attempted cyber attacks that occurred every day through 2020, showing, for example, malware increased by 358% overall, and ransomware, that stuff that will encrypt your disk and demand money to decrypt it, by 435% as compared with 2019. It's simply astonishing. We're also seeing that phishing attacks have accounted for more than 80% of reported security incidents. And by 2023, Cisco tells us that the number of distributed denial of service attacks worldwide will be 15.4 million. So you can see that the attackers, they are thinking at all levels of the stack. They're thinking about the connectivity between all of those things, and they're exploiting the gaps between in our thinking to be able to attack end users, to be able to attack infrastructure, to be able to attack your even your disk with your beloved family photographs on it. They are scheming, nefarious, and very, very intelligent people. And so I'd like to bring up a quote by John Lambert, who's a distinguished engineer at Microsoft and like a security guru. This really resonated with me. Defenders think in lists. Attackers think in graphs. As long as this is true, attackers win. And this really resonated with me because, of course, IT systems are complicated, interconnected systems of computers and software and people and routers and switches and networks and all of that stuff. If we're thinking in terms of lists, have I closed the port on the firewall? Tick. Have I disabled UDP on this port? Tick. Do I permit plain text FTP? Tick, that kind of thing. Then we're thinking in a very piecemeal way. We're not thinking about the whole system and how transitively one part of a system can affect another part of a system. Now, don't get me wrong, I think checklists are amazing. A good friend of mine is Len Bass, who was at Carnegie Mellon at the Software Engineering Institute, and he pioneered the idea of software checklists there. But these kind of checklists need to be distilled from a holistic graph model of our systems that we're trying to protect, not the other way around, because that's the way that our attackers are thinking. They're not just thinking about, oh, should I hit this port on this firewall? That's merely one tool in their arsenal, but they have a broad thought about how they're going to penetrate and percolate through a system. So what we need to do is understand that our assets are connected to each other by relationships, by security relationships. Attackers breach a network by landing somewhere in it, somewhere there's a vulnerability they can exploit, and then expanding through this graph. And so they might land using a technique like spear phishing, that they might land because you've got an unpatched old operating system somewhere. They find the vulnerable system and then they spread as a graph through the system. In fact, what they're typically doing is, for the subgraph they're attacking, they're looking to build a minimum spanning tree. They're looking to build the cheapest possible model of exploiting all bits of that subgraph as they can. So least effort for them, maximum payback for them too. So the graph of your network systems is the set of security dependencies that create equivalence classes amongst your assets. The design of your network, the management of your network, software and services used on your network, the behavior of your users even on your network, all influence this graph. And if attackers compromise any of them, they have a path to compromise the system. And in fact, once they're in the system, they can carve paths through it. Scary, scary stuff. So why do we need graphs to solve a cybersecurity problem? Well, it's because your team, your security team, needs a holistic view of the enterprise. It needs to be able to identify assets and assess risk to assets and processes. It needs to protect systems and services, especially the crown jewels. We also need to detect anomalies. Hey, there's a connection between those two servers. That shouldn't be the case. And we need to respond rapidly. We need to be able to take a Hercule Poirot or Sherlock Holmes style set of signals, follow the breadcrumbs through the graph, and figure out what's happened. Look for connections between systems, pathways through our IT systems that indicate that we've had an incident, rather than just looking at isolated metrics and in our mega brains trying to figure out what the connection may be. Let's delegate that to our tools and get the tools to run high performance analyses of these problems and surface out to us when we have an incident, so that when we have an incident, we can recover quickly. Holistically, all of this makes sense if you think in graphs. And if you're thinking in graphs, you can figure out how to enhance your security policies by using those relationships. All of this means that you're going to be thinking in a model of connected data, a world natural to me after 11 years, Lance, at Neo4j, 11 and a half years strictly. It's natural to me to think of the connections in the data as being as valuable as the data itself. So we have loads of stuff happening, of course, in graph world, not only cybersecurity, but we have networks of people. So you can understand, hey, if this person or this login is compromised, who are they connected to that might be compromised as well? And do I need to pay closer scrutiny to them? We can look at transaction networks. So we can look at work that's been transacted or value that's been transacted over a network and try to identify paths or subgraphs or cliques which are known or suspected to be nefarious actors, and we can start to scrutinize those more. On the more positive side, we can assemble all of our learning and understanding into things like knowledge graphs. So we can bring the knowledge graph stuff to bear on our missions, to inform our missions, to keep our systems safe. So connections are core, I think, to modern intelligent apps. Graphs are, I think, at the heart of building intelligent apps. They're really useful for making new, insightful discoveries about your business, your customers, whether it's cybersecurity, whether it's recommendations, or indeed the flip of recommendations, which is I recommend that this person go to jail, whether it's keeping track of all of your data assets and the provenance of them and where that data has been shipped around to, or security analysis, or indeed other things that aren't even cybersec, drug discovery, machine learning, what have you. Graphs are really useful for that. So I think that graphs are becoming a requirement for this new breed of intelligent apps in cybersec and elsewhere. So it's these relationships, in addition to the data, that form the core of a growing variety of use cases. But importantly, they give you this both direct and transitive view of your data that enables you to reason more strongly about what's going on. Relationships between records actually start to become the DNA of your business that drive everything you do. You'll see the patterns of your business played out in these relationships in the graph. And of course, graphs are the natural way to reveal, manage, and use those relationships. What I really like about them is that they model the way the real world works. There's no impedance mismatch between how the graph works and how the real world works. The graph is a high fidelity model of the real world, and they represent what's important in your business. Now, I work at Neo4j, so I'd be remiss if I didn't tell you a little bit about why I think your graph, your cybersec solution as a graph, should be on Neo4j. We are the creator of the property graph. We have thousands of customers around the world. We are a worldwide company. We have our HQ over in Silicon Valley, as you can tell from my very Silicon Valley accent, and then all around the world, from Silicon Valley through Europe to Asia and Australasia and so on. The industry leaders use Neo4j, 20 of the 25 top financial firms, 7 out of the 10 top retailers, 7 out of the 10 top software vendors. And we deploy your way. You can take Neo4j, you can run it in your data center, you can run it on your cloud of your choosing, or you can run it in the cloud. We have a DB as a service called Neo4j Aura. So all of this stuff is very straightforward to access and use. And actually, even if you've never used a graph or Neo4j before, learning how to build a picture of your security system is relatively straightforward. Now, you're not alone in this. Neo4j has, over the years, built up a huge community of users who are walking the same path, if you'll excuse the pun, as you. This is 2,000 startups, 800 enterprise customers, 80 customers in the enterprise added in 2020. And these are blue chip names, as you can see here. We were the first graph doing graph-based machine learning for the enterprise. We pioneered that, and Forrester recognized this. We are by far the leader in the Forrester wave for graph data platforms, and our adoption is growing. We have been the spearhead of graph databases for the 11.5 years I've been at Neo4j, if not longer. And graph databases themselves, as you can see on this chart here, have really accelerated other types of databases over this, I think, very interesting decade of innovation in databases generally. You know, there are 200,000 plus Neo4j developers around the world, 72,000 meetups. We are the #1 graph database in DB engines, and indeed we're in the top 20 of databases generally, which is great because some of those databases include things like Microsoft Access, which are hugely deployed. There's 2 million downloads of Neo4j. There's 144 million Docker polls. About 90% of folks are already running Neo4j in the cloud, so it should suit your environment. Of course, Neo4j isn't just about the database itself. We have a bunch of really useful tooling and integrations around the side. So if you are a developer, we've got you covered with productive frameworks, with good drivers and APIs. For business users, we're able to give you GraphQL support. We're able to give you integrations into Tableau and so on. We also provide you with a tool of our own called Bloom, so you can start to explore the graph in a kind of Google style if you're a business user or an analyst. If you are a CIO, all of this stuff is built with a common query language called Cypher, which is currently undergoing standardization as ISO GQL to match ISO SQL. And then all of this stuff, if you want, we can push it into the cloud for you. It's a rather, I'm proud to say, a rather boring operational experience, as you would expect from a database. So my time is nearly up, but just let me leave you with a use case. So MITRE built a tool called cygraph several years ago. It was a tool for protection of mission critical assets, for improving network security posture and maintaining situational understanding in the face of cyber attacks. Now, cygraph captures complex relationships amongst entities in the cybersec domain, along with how mission elements depend on the cyberspace assets. And what this does is it forms a foundation for a common operating picture for cyber attacks and defenses and mission impacts. And so what you can do with cygraph is you can do pattern matching queries which traverse across the graph of interrelations according to some user specified constraints. And these give you highly focused clusters of high risk activity from the otherwise swarm of complex interrelationships. So you're able to extract signal from noise. You can join the disparate data points into some actionable units that you can then investigate. So what I'm saying here is not only are you able to build your own tools in Neo4j to monitor your cyber systems and keep them hopefully healthy and free from attacks, but there are also commercial offerings out there now that are building this kind of technique into them and going to market with them. So finally, look, MITRE aren't alone. There are thousands of teams around the world that trust Neo4j with their most challenging and complex connected data problems in cybersec and elsewhere. Our customers are solving these valuable problems with Neo4j and graphs today. And I would just implore you, come build with us. It's amazing tech. I'm always amazed by the innovative use of our tech to solve these kind of life-changing problems. Neo4j and graphs are a wonderful thing to build on. You'll build wonderful systems, and I hope you'll have fun doing it. So thank you for your time. I hope you have a brilliant event today. It's just a wonderful set of people speaking. If you do have any questions, pop them in now and I'll get on to answering them. Thank you very much, everyone.
Thank you so much, Jim. That was great. And the cybercrime numbers and statistics you mentioned are just staggering. It's terrifying, actually.
Isn't it just, right? It's like,
oh my gosh.
Goodness.
So we do have some questions that have come in, and I want to remind the audience if they have questions, they can submit them using the questions tab located on the top of their screen. But here are a couple that have come in while you were speaking. So here's one that asks how to best use graph data models to organize data, especially in a cybersecurity world.
Yeah, I mean, that's something where I could spend days with you and your systems trying to pick the perfect one, because I think each system will differ. But broadly speaking, you know the layout of your network. I think one of the most straightforward first steps to do is to use the metrics coming off your network to build a graph of what's happening. Right, so you know from the metrics that you can harvest that certain machines are connected to other machines, or certain apps on VMs are connected to certain physical hosts which connect via switches to other machines, and watch that traffic. So build that model. It will be, in the general case, a very helpful ops model for knowing exactly what your assets are. Then on top of that, you can start to run queries to look for weird things like, hey, this machine over here in the web tier appears to be speaking to a machine over there in the backend apps tier. And that shouldn't be the case, because it should actually come through this firewall and go to this mid-tier server and so on and so on. So you can start to look for patterns that you know shouldn't be permitted theoretically according to your network architecture, and get the graph to highlight those when they happen in real time by harvesting the metrics, streaming them into the graph database, then pattern matching against those queries. You can see even with that simple idiom then, and your domain knowledge, whoever the questioner was in your domain, that you can then start to build more sophisticated patterns that will detect all kinds of intrusions. If you're going to be super sophisticated about it, you could even auto ML it, so the auto ML will start to suggest patterns of interest for you, which I think is the kind of very sophisticated end of the spectrum.
Oh, that's very cool. Very cool. Thanks for that answer, Jim. And here's another one that asks, are there key data graph methods to build up intelligent threat analytics capabilities?
Yeah, I think so. Again, it's a slightly broad question, so forgive me if I'm not quite on point. But what I mentioned a moment ago, so building up that model, that's a really good first step. You can then run analytics over that model. So if you want to understand, for example, peculiar cliques, peculiar groupings, or peculiar paths, or if you want to look for things like systems that are busy that perhaps shouldn't be, so you want to look for centrality and that kind of thing, there's a full library of analytical tools that you can deploy onto your graph and get the database to do the work for you. So you could do things like say, hey, database, show me the most popular systems that are being used by users in North America, and you'll get a centrality computation there, which will be a computation of paths through the network. If that looks fine, if most users are doing boring things, all good, but you might find that some users are doing unusual things, low centrality in this case. Those are the outliers that you might want to look at just to make sure that nothing peculiar is going on there. But generally speaking, apply those algorithms to your graph. You'll get insight yielded from them, from those unsupervised algorithms that will give you ideas about where to look for other things. And once you've found those nefarious things happening, then you encode them into your system so they can't happen again.
Great, thank you. And I know we're so tight on time, but I want to squeeze this last question in. So how much of a role does AI, ML, and data science play when solving real-world cybersecurity challenges?
Yeah, I think quite a big role. So the analytics stuff that I just mentioned, that's part of data science, right? So you're running algorithms and kind of understanding what in aggregate the graph's telling us is useful. But I think there's a complementary element to this, which is if you've got a graph, which is which you appreciate, it's a good graph, it's a good representation of your system, it's providing you value, then you can run analytics on it, and that's part of the analytics tradition. But you can also take that graph and use it to train an ML model. So you can actually have this nice complementary thing where you're running analytics over the graph. You're using both the graph structure, the data in the graph, the relationships, to build a good model, a good ML model based on the graph topology or things like node centrality or page rank or so on. And then you can use that ML model that you've built to start making predictions about where the attackers might be, where they might move next, and so on. So I think if I had an ideal solution, it would be graphs for capturing the real-time data, running real-time queries and alerting and so on in real time. But I'd also be pushing that data down into my ML model and asking my ML model to start thinking effectively like a criminal and suggesting to me what's going to happen next. And that would be, I think, a wonderful tool to have. And I think it's actually commoditized to the extent where particularly larger enterprises could well build that at a relatively modest development cost.
All right, thank you. Thank you so much, Jim. It's always such a pleasure having you here with us. And for those in our audience, I just want to let you know our next session will be starting in just a few minutes, so stick around for that. And Jim, thanks again.
Thank you. Have a lovely day, everyone. It's going to be a wonderful set of talks. Stay safe. Bye-bye.